Welcome back to another 1 hour crash course where I take a single topic and break it down into the most important pieces of information that will take you from a complete beginner to someone equipped with just enough knowledge to hit the ground running. Today, I'll be talking about how to code, which I might say is a pretty loaded topic to cover in just 1 hour. So I'll set out this disclaimer before we start, and that is you will not become a proficient coder in any specific language by the end of this 1 hour. That said, what this course will do for you is lay out the landscape and kind of describe what coding's all about. It will walk you through the basic elements of coding, including how a computer works, and will provide you with some resources that will actually teach you to code over a more extended period of time. So, before we jump into the details, I wanted to just take a step back to 10,000 feet and better understand what coding is all about. Now, you're going to have tons and tons of different people that will tell you coding is this or coding is that, but in my opinion, coding is not necessarily a specific thing. It's more of a way of thinking, a way of solving problems, and at its very core, all coding is writing some form of text into a file that we can read as humans and executing that file on some physical computer. And the reason you might do this would be for, you may want to automate a trivial task that you have to do every single day, or even something as complex as creating a self-driving car like a Tesla. So the first thing that I wanted to show is a very, very simple program that I wrote one afternoon. And what this program does is it actually takes a Python program and it will open up a fake web browser. And what it will do will go to a specific subreddit where there are several pictures of nature, and it will download them to my computer. Now, I did this project one afternoon because I have an iPad, and what I wanted to do was download a couple hundred photos that I could use as my iPad's screensaver. I had actually jailbroken the iPad so it had like a rotating screensaver. Now, instead of going to the internet, and if we go open a new browser and we go to the subreddit that I scrape images from, when it finally loads, we can scroll down and click on a picture, and then we can right click it and we can save image as. And what we could do is then give it a name, Reddit image 1, and then just save it to our downloads. Now, that is perfectly fine, but what if I wanted to automate this task? What if I didn't want to sit here all afternoon right-clicking and downloading images? Well, what I could do is I could write what we call a script, which is just code that serves a single purpose. And that is what you see right here. So I have a single file. This is, we'll talk about this text editor a little bit later, but I have this single file which has a bunch of Python code. And there's no need to understand what this is, how it works. Just know that this Python code is going to open up this particular page. It's going to look at a picture. It's going to measure the aspect ratio of the picture, and if that aspect ratio is within a certain bound, then it will download it to a specific folder on my computer and give it a name, Reddit image 1, 2, 3, 4, 5, and so on. Now, the reason we had to do this aspect ratio is because my iPad has something like a 16 by 9 aspect ratio, and a photo like this, which is vertical, would not look so great. So I wanted to avoid these photos. So let's go ahead and run this. all I have to do is type python redditscraper.py, and what you'll see is this is actually going to open up a browser. I did not open this browser up. The program did. So it navigates to this link, and then what it's going to do is it's going to scroll down several times so that more pictures are actually shown on the screen. Let's go ahead and wait for this to end, and I will come back and show you kind of what it did. Okay, so our scraper has completed, and we can go into this folder here on the left. This is simply a folder that's sitting on my computer. Open it up, and we see that there are a couple of images. If we click on the images, we can see that these are some of the photos that were online. So we've successfully downloaded some of the images with this simple script. And the beauty of it is I never have to actually watch this script. So if I wanted to download, rather than the 5 images that I downloaded here, I could type in, all I'd have to do is go into the script and change the number of pictures that I want to save. So right here, I could just change this to 500. And when I run this script, I could just walk away, go do something else, and my computer is going to sit there and download up to 500 photos for me. So it's much better than right-clicking and clicking Save As. Now that's just one example of how we could use code to make our lives easier. But this looks a little bit complex for us. Now, something even more simple is a little utility script that I wrote, and what this does is it takes images that I have screenshotted and moves them quickly to another folder. So often when I'm writing blog posts or doing something kind of repetitive and I have to take screenshots, what that does is it downloads to a specific folder on my computer, and then what I have to do is I have to open up the Finder window and right-click, rename, type in the new name, and then drag and drop it into the folder that I want. Now, I thought that this was a little bit tedious, so what I did was wrote a single script that will do it for me. So let's go back to the internet, and maybe instead of downloading, I just want to screenshot this. So I click Command-Shift-4 on the Mac, and we go ahead and screenshot that photo. You can see it popped up in the bottom right corner. Now, what this did was it saved to my desktop, which is the default place that a screenshot will save. And this script that I'm about to run, it's called movepic.zsh. But if I run movepic.zsh and then I give it a name, so my screenshotted photo, and then I type dot, which means the current directory that we're sitting in right now, press enter, and what that does is it goes into my screenshots folder, finds the most recent screenshot, and then moves it to where I have designated. So here's our screenshot, which is now sitting in the file pane on the left. So these are just 2 very practical examples of how I've used code in my own life to make things easier for me. But as I said, code could be far, far more complex, and you see it everywhere. So anything from the code that runs the shopping cart on Amazon to the Tesla that drives itself. This is all run by some form of code. I hope that this brief introduction kind of gave you some perspective and opened your eyes up to what code is and what can be possible when you do know how to code. We've talked about what coding is, but you might be wondering to yourself, am I capable of writing this code? Now, in order to answer that question, I just wanted to briefly introduce you to something called Cloud9, which is an online code editor. And as you can see here, we've got a workspace that we can use to get our feet wet with this coding thing. Let's go to a file here. It says cleanroom.txt. .txt is just the file extension, just means that it's a text file. Now, the reason I have this file open is to demonstrate to you that you actually code every single day of your life. Think about the process of cleaning your room. How does that work? Well, it's probably intuitive for you and you just do it. But if you break down the individual actions that you're doing and the decisions you're making, you're actually coding when you clean your room. So let's break this down. When you clean your room, you have a bunch of items on the floor, and for each item, notice I'm saying for each, this is a loop, we'll be talking about that later. For each item, we're going to ask ourselves, if that item is a piece of clothing, I'm going to fold it and put it away. Else, or in other words, if it's not a piece of clothing, we'll go ahead and assume that it's a piece of trash. And if it's a piece of trash, we'll throw it away. So if piece of clothing, fold it and put it away. Else, throw it in the trash. So what we're going to do is write something called pseudocode. Pseudocode is something that programmers use to map out the logic behind their programs. Now, this is not actually a coding language, and if you tried to execute the program, it's not going to work. But it does help you clarify your intentions before you write a program. So what we're going to do is we're going to say, for each item on my floor, we're going to say, if the item is piece of clothing, fold it, put it away. Else, we can assume that it's a piece of trash, so we will put in trash. Right there, we've written a program for cleaning our room. So if you thought, oh, I can't code, I'm not capable of this, then you've been thinking about it wrong, because everyone in the world does some form of coding on a daily basis. It's more a matter of how much time are you willing to put into this. So another question that you might be asking is, what language should I learn? Well, you've got anything from Python, C, C++, C Sharp, Java, JavaScript, you've got Go, anything. There's tons of programming languages. There's hundreds and I don't know, maybe even thousands of programming languages. But I'm here to tell you right now that you should not be asking this question at this moment. At some point, a client is going to ask, can you please write me an application in Java? At that point, your question is answered because you've got to write Java. And to be honest, these type of requests will happen often. Although many programmers will kind of get siloed into a specific tool set, you probably will encounter different languages throughout your career. And despite how hard it might sound now, it's actually not that hard because all the programming languages share a common set of traits that you'll be able to translate between all of them. One of the questions that I had when I first learned how to code was, how does a computer actually work? If I was going to write code, I wanted to know what was kind of going on behind the scenes. Now, I don't have time to get into the details, and to be honest, I don't fully understand the nitty-gritty details of how a computer works under the hood. That said, I do have a couple resources for you that you can look to understand this a little bit better, and then we'll go through a brief explanation. The first resource is a course called Nan to Tetris. Now, this is a course that takes you from scratch to building a basic computer that can run a game like Tetris on it. Now, this requires you to actually code, and the course itself does not teach you how to code, so I would not recommend starting with this. But down the road, it's a very useful course. Now, there is a book out there called Code, which, although it's a pretty difficult book to read, and it's definitely not a page turner, it does give you a better idea of how a computer works. It talks about binary code, ones and zeros, logic gates and transistors, and all the other fun stuff that goes on inside of your computer. Now, for starters, we can go ahead and demonstrate how code works with a simple demonstration. But before we do that, we need to understand something called an abstraction. Now, an abstraction is something that you experience on a day-to-day basis, just like cleaning your room could be considered a computer program. An abstraction might be taking a shower. When you turn the knob to turn the water on, that is an abstraction because you're not thinking about all the things that are going on behind the scenes to get that water to where you are. In reality, you have to collect the water, you have to store the water, a company probably does that somewhere, then the company has to distribute the water out to your apartment or your home, and then at your apartment or home, the water needs to be heated, and eventually it'll be run up through pipes, and when you turn the knob, the water comes out. Now, as the end user yourself, you don't care about all that stuff behind the scenes as long as the water comes out. Now, code is very similar to this in the sense that we write code and we expect it to work, but we don't care about all the things going on underneath the surface. A computer is just a big abstraction, just like your shower faucet. And to better understand the basics of how your computer works, we're going to go ahead and go to a site called Cloud9. Navigate to c9.io and go ahead and create a free account here. Once you've done that, you'll be directed to something that looks like this, a dashboard, and you're going to click Create a New Workspace. Name your project, maybe How a Computer Works, and then click the C++ template. Once your container has fully loaded, and a container is just a word for what we're using here, I'll get into that later, go ahead and close the README, and then go over to the pane on the left. This is the File Explorer, and find the file that says hello-c-world.c. The .c at the end indicates to us that this is a C program. If you double click it, it'll open in your editor and you can view the code. It's pretty simple. All this program does is print the phrase hello world to the terminal down here when we run it. Now, we can't just run this program as it is because the computer doesn't actually know how to run we haven't written it, but what someone has written here. The computer doesn't understand words like main and printf and hello world. The computer only understands ones and zeros. So with any language, you have to get the language that coders like us write and do something we call compile it down into ones and zeros. So no matter what language you write this program in, it all eventually is turned into the same exact ones and zeros. The reason that I picked the C programming language to demonstrate this is because we have to go through a very manual process of compiling the code down to something we can run. Now, with higher level languages, as we'll talk about, like Python, you don't have to go through all of these steps. And those languages are the languages that you'll probably be coding more often in. That said, let's go ahead and get down to the terminal and type the following command. We'll say GCC. That represents the GCC compiler, which is basically just a bunch of code that was already written for us. And what that code does is it looks at the code that you're quote-unquote compiling and performs operations on it until it becomes something that a computer can read. Now, we're going to pass this command a little option, -s. The reason we do this is because we want the GCC compiler to look at the code in front of us and compile it down into code called assembly code. So we'll say GCC -s and then provide the GCC compiler with the name of the file that we want to run. So hello-c-world.c. If we press enter, you can see that on the left-hand side, we now have a new file. It's called hello-c-world.s. The .s extension means that this is a bunch of assembly code. Now, what is assembly code? Well, assembly code is that one step above binary code, which is the ones and the zeros that the computer can actually run. The reason that we have assembly code like this is so that it makes it a lot easier to develop coding languages. If I'm trying to write myself a new coding language from scratch, similar to something like C or Python or JavaScript, all I need to do is make sure that my compiler can get my code into this assembly code. If this doesn't make a whole lot of sense, that's totally fine. I just am doing this as a demonstration for those curious. Now, of course, we want to get this down to ones and zeros rather than just assembly code. So the second time around, what we're going to do is we're going to simply type gcc-o, that's an O as in letter O. We'll give it a name that we want to run. So we'll say my executable program. And then finally, we'll pass in the name of the C file that we want to completely compile. Okay, so instead of compiling it down to assembly, as we see on the screen, and then stopping, what that command did was it actually compiled the Hello World C program, this thing right here, all the way down into binary code. And we can see that my executable program, if we open it up, it's a bunch of random symbols that don't make any sense. These aren't actually what they are, it's a bunch of ones and zeros, but the text editor can't display those. So this program right here, my executable program, is simply a bunch of ones and zeros. To run it, we'll come down to the terminal, we'll say /, which means I want to run something, and we'll pass in my executable, and I don't even have to finish typing this, I can just press tab, and it recognizes what I'm trying to do. I'll now press enter, and you can see that the program printed hello world to the terminal. Pretty cool, huh? So this is how the process of compilation works. I know I only touched on the very surface, but hopefully it gives you a better idea of how we take something like this that a human can read and code and compile it down into this, which a computer can read and execute. All right, so at this point we've gotten through a lot of the conceptual things, so I think we are about ready to start coding and learning what this whole coding thing is about. So to get started, I'm going to walk you through a few setup steps. You don't need to worry about what's actually happening. The point of this is more to just get you ready to code. So the first thing you need to do is go to Cloud9 and click on the Create New Workspace. Okay, so you want to name this whatever. So we can go ahead and say How to Code Workspace. And then we'll scroll down. And in this field right here, we need to enter the repository that I've created for you. So you'll navigate to this repository here. It'll be linked below in the description, or you could just search my username and go to this repository. And then what you're going to do is click on this button up here that says Fork. So what this Fork button does is it will take all of these files that I've created for you and will copy it over to your GitHub account. And if you don't have a GitHub account, that's totally fine. Just take a few minutes, set that up. It's totally free. You'll use it every day. So once you have that set up, you'll click the Fork button. I actually can't fork it because it's my own repository. But once you click that, it will kind of clone it over to your account. And then make sure that you are on your account page, not mine, So it'll be indicated by, it'll say your username, this description, and then it'll say forked from, and then it'll say my username. So that's how you know that you're on your page. Once you're there, go down to this little clone or download button, click it, and then make sure that you have the HTTPS version and click this little copy button. Okay, so that will copy it to the clipboard. We go back to the new workspace, paste that repository in there, and what that will do is when this workspace is created, it will download all of that repository onto the workspace. And finally, what I want you to do is click the Python, because we're going to write a very simple Python program. So we have all this set up, name it, put the GitHub URL, and click Python. Create workspace. All right, so we have our workspace set up. At this point, let's make sure that everything's running correctly. If you did the last few steps right, what you can do is type the word Python in the terminal, press enter, and it will open up a Python shell, or this is actually called the Python interpreter. From here, you can type any sort of Python command. So, or you could do something as simple as 3 plus 3, and it'll say 6. So that will enable you to make sure that you did the previous steps correctly. Go ahead and press Control D, I believe, Control D to exit the Python interpreter. Your Cloud9 workspace is completely set up. So now it's time to run your first program. This will be a Python program. I chose Python just because it's a pretty easy language to catch on to. A lot of schools are now teaching Python as the first language rather than C, as we showed earlier. So let's just go into this source code folder that I've written for you. And you can see that there's a cleanroom.py file. We're actually going to take that analogy that we used about cleaning our room and put that into my rendition of code. To run this, we will type Python source code cleanroom, and the program will run. Pretty easy, right? You now know how to code. So you've got your Cloud9 workspace set up, and now it is time to run your first program. I have already written this program for you to make it easier, but how would we go about running a program when we don't actually know how to write the code? I'm going to take you through a few steps, and for now, just watch, and we will eventually walk through how I am doing what I'm doing. Before we do that, go into the source code folder and open up the cleanroom.py. You can see that this is the file that we're going to run. It's pretty short, but I know a lot of the symbols in here don't mean much to you. Go ahead and pause the video, look over this file. I would spend 5 to 10 minutes just gazing at this and trying to make any sort of sense of it. And then I'll kind of walk you through it, and we'll eventually, by the end of this course, know every single line of this particular program and in general what it means. To run this program, we can go down into the terminal and type Python, give it the path to the program, source code /cleanroom.py, and then when I press enter, I'm going to go ahead and give us some more room here. We can see that the output of the program is what is highlighted below. So this program, although very simple, it just sorts different items into their appropriate places. We could even go into the program and change our data. So I've set up item 1, 2, and 3. But what if we wanted to add another item? We could say item 4 equals, give it a type of trash, and then we'll say the description will be, I don't know, some sort of trash, so a gum wrapper on the floor. So then we add that to our items in the room array, save the file, give ourselves a little bit more room here again, type clear, and then run the program again. And now it added this fourth line of output. It said, I threw the gum wrapper in the trash can because it is trash. So I know this does not make a whole lot of sense at this point, and before this will make sense, we need to cover the topic of the terminal. So these commands I've been typing in, the clear command, the Python source code clean room, that's a command. All of these commands are something that you need to understand in order to do anything in coding. So we're going to jump out of Cloud 9 for a moment and go to my local MacBook Air to demonstrate some of the common commands that you might see a coder using in the terminal. So before you get all confused, why are we going to my MacBook Air versus this Cloud 9 environment? The reason I'm doing that is because we can conceptualize my local computer a little bit better. I'll show you what I mean in a second. So first we'll open Finder, and second iTerm. So iTerm, this black area right here, I'll move it around so you can see this is just a little application. This is the terminal application for the Mac. It's actually not the default one, but I prefer this iTerm. Then, of course, you have the Finder window. For any Mac users out there, this is the file system. So if you're on Windows, this would be the equivalent of the File Explorer. And as you know, you can see all of your favorites, your locations, your drives, etc. I've went ahead and set up a sample file system. So this file system is sitting on my desktop right now. Of course, I'm not going to be showing all of my files on my computer to you, so that's why I put it on the desktop. But I wanted to have these screens put right above each other because if you can understand this file system or the File Explorer, then you can understand how we use this terminal. So we'll first go through the thing that we're all familiar with, and that is the Finder. So if you click the file system, click the drop down, you can see there's another folder in it called parent. If you click that, we can see there's another folder called child. And if you click that, you can see that there are 5 simple text files and a single grandchild folder. If you open the grandchild folder, we have 2 more text files. Pretty simple. There's nothing really in these text files right now because that is not the point I'm trying to make. What I'm trying to get at is the fact that these files have a hierarchy. And what we call the different locations of each of these files is called a path. This will make a little bit more sense when we get into the terminal here below. Let's go ahead and use our first command, which is pwd. And before I do this, I'm going to create a file. So I'm going to just pick this file1, which is sitting in the child directory. So I will use the built-in Vim text editor. Eventually you will probably stumble upon Vim in your coding career. I'm not going to be explaining it in this video. But if I go to Vim and I type in the path of the file I want to edit, so we'll go parent child file1.txt, it will open up a terminal where we can write stuff to this file. So the following will be the commands that I'm going to be explaining here and are by far the most common commands that you will be using on a day-to-day basis, no matter what kind of coding you do. Those commands are cd, pwd, ls, mkdir, touch, cp, mv, and rn. So that is the general commands that you definitely will need to know. And I'm going to type :wq. That is how you save and exit the Vim terminal. Oh, and I forgot one command actually, so we'll go back. If we go to the bottom and type cat, like a cat, this will actually print out the contents of a file, as we'll see now. So if we type, instead of Vim, if we say cat parent child file one.txt, we will see all of the text that we just wrote into that file. But I'm getting ahead of myself, so let's go back to the beginning. Let me drag this down so that we can see both windows. Type clear, that clears your terminal. You can still obviously scroll up and see the history of commands, but it cleans up your workspace. The first command that we're going to be looking at is pwd. And what that stands for is print the working directory. This is very useful because with this terminal, unlike the file explorer above, we can't necessarily see where we're at in the file system. Of course, we can see that we're in the file system folder or directory, but we can't see where that is in relation to the rest of the file system. So if I type pwd, what it's going to print is the absolute. That's a very important word. When I say absolute, that means from the topmost path of the entire file system, it's going to print out the path to where I'm currently sitting right now. So I pressed enter, and you can see that I am in the root directory under users, Zach, desktop, file system demo, and then file system folder. So that is what is called the path. And it's very important that you understand what this means. So there is the absolute path, which is highlighted right here, but you could also have something called a relative path. If I wanted to demonstrate that, let me just go ahead and introduce the next command that we need to learn, which is cd, or change directory. What this does will take your current position, which is indicated above right here, and it will actually change it to a different place. So above, we can see that right now we are sitting, our terminal application is sitting on this highlighted row, the file system. What if I wanted to go down into the parent? To do that, I would type cd, and then since I don't want to type out the full path, I can just use the relative path. So I can just type parent. And what I did right there, I know this is confusing if you just started, I typed PAR and then pressed tab, which will auto-complete the command. So parent, I press enter, and what I've done is now I started at file system, and then now I'm at the parent. So I'm now sitting right here. I could have also done that. What I'm going to do now is go up one directory by typing cd ... That takes me up one directory. Now I am back to my file system. So what I just did was I started here at the file system. I typed cd parent to go down into this folder, and then I typed cd ... to go back up to the file system. Type clear to clear our terminal, and now I'm going to navigate to the parent directory with a slightly different method. So previously we had typed cd parent. We could have also typed cd ... which represents the current directory, / parent. But what I'm going to do now is type cd /, which means the topmost folder in my entire computer, and I will type / users Zach, and then desktop, file system demo, file system, and then finally parent. So that is what we call using the absolute path to navigate to different directories. So if I type cd this path and press enter, we end up in the same exact spot that we did previously. So to recap, let's go cd ... to go up one directory. We're back at the file system right here. And recap is we can go down into the parent by typing cd /parent or cd parent. Those are the same thing. Or we could type cd and type out the entire absolute path. So hopefully this gives you an idea of the difference between an absolute and a relative path. This is one of the most important pieces of knowledge that you can have using the terminal, and it is, although it's going to be very unintuitive and clunky at the beginning, you'll find yourself confused where you're at. This will eventually become second nature. You'll be able to go around the file system really quickly, parent child, cd ... cd ... I'm back to the file system. What if I wanted to go to grandchild, cd parent, child, grandchild. Now I want to cat out the contents of file1.txt. There's nothing in it. You get my point. I'm very comfortable at this point navigating through the file system via the terminal. Now let me type another command. We can use that ... syntax to go up multiple directories. And the way we do that is ... slash ... slash ... slash. So I went up 3 directories. And we are at the file system again. So we were at grandchild, then we went up 1, up 2, and up 3 by typing cd ... slash ... slash ... slash. Hopefully you're getting the hang of this at this point. Now if you ever get lost, there is a very useful command called ls. And what this does is it prints out a list of all of the files and directories that are in the current directory you are sitting in. So again, we'll type pwd to find out where we're at, and it prints out the absolute path of where we are sitting. Then I'll type ls, which prints out parent. If I'm at the file system, I only have one directory underneath it. So I typed ls in the file system and I get printed out parent. Now if I went down another level, if I went into parent, cd parent, and then I typed ls, let me clear it first, I will see child. So the parent has one directory beneath it, and that is child. Now let me go into child and ls. And now you see 5 files and a grandchild, as you would see right here. So 5 files and grandchild folder. If you wanted a little bit more descriptive, a more descriptive printout, we could type a command called ls-la. And what that will do is print out a little bit more verbose output. So let me extend this up so we can see the entire output. Now what we're seeing is 2 lines representing the current directory and the previous directory, or the higher directory. We then see something called .ds_store, which is some sort of hidden file that every hidden file is indicated by a dot. So if I were to create a file with a period before it, the normal ls command would not display it. In my file system, as you see here, we don't see anything called ds_store. The file system, or the finder, will not display it either. Okay, so we'll clear that. At this point, we have covered the pwd command, prints the working directory. We've covered the change directory command. Let's go back to our file system. We went one too far. Go back to the file system, clear it, and then we learned the ls command, which will print the files and the directories in our current working directory. And we also previously learned the cat command, which prints out the contents of a particular file. So the only file in this entire hierarchy here that has anything in it is the file1.txt within the child directory. So we could type cat and then give it the relative path of that file to print out that file. So the relative path from the file system, we're sitting here at file system, would be parent child file1.txt. So cat parent child file1.txt, and it prints out the contents of the file. Clear it again. You'll notice yourself going through that flow of typing a command, typing clear, typing another command, typing clear again. You'll get very used to this over time. Now there's a few other commands that we need to learn, and let's see what we've got. We need to learn how to create files and create directories. Let's go down to the grandchild folder to do this. So to do this, we will type cd parent child grandchild to navigate to the grandchild directory. If we type pwd, we are now in this path, the parent child grandchild directory, or visually we can see it right here. So what would happen if we typed ls? We would expect to see file 1 and file 2. So let's try that. We see file 1 and file 2. Great. What if we wanted to create another file or another directory? Why don't we create another directory with a new file in it? To do that, we type the mkdir command, which stands for, this is at least what I say, make directory, and we can type in a new name for a directory. So we could say great grandchild. And what this is going to do is we're currently sitting in the grandchild directory. So what this is going to do is create another directory in that directory right there, named great grandchild. So you can see above, it created the great grandchild folder or directory. I keep using these interchangeably because folders and directories are the two words for the same thing. Now that we have created that folder, we can put a file in it. So we could do this in multiple ways. We could give it the relative path, so we could type touch, which is the command to create a new file, and we could type great grandchild / name of file.txt. If we pressed enter right there, it would put a new file in the great grandchild directory. But to keep things simple, I don't want to get into the longer commands. Why don't we change directories into the great grandchild directory? Now all we have to do is type touch new file.txt. And you can see we just created a new file in the great grandchild folder or directory. So pretty cool. We have the make directory command and the touch command for creating folders and directories. Now, what if we wanted to delete a file or delete a directory? The way that we can do that is by using the rm command. So I'm going to create another couple files in the great grandchild directory just so we can experiment. So we can actually pass multiple files to the same command. We can say touch file1.txt, file2.txt, file3.txt. And you can see that that just created these 3 files in our current directory. Type clear to clean up our space. And now let's say we wanted to delete the new file.txt right here. In the Finder, you would just right click, move to trash. In the terminal, what you could do is type rm and pass the name of the file. So we're in this directory, so we can just type new file.txt. If we were up one directory, so let's do cd ... we're now at the grandchild level, so right here. Oh, I closed it. Let's go back. I'm not sure what we're doing here. Okay, there we go. So we are currently at the grandchild level, and to delete a file in the great grandchild level, we have to pass the relative or absolute path to the file. So if we're sitting in grandchild, we could type rm and then give it the directory great-grandchild / new file.txt. And when we enter this command, this new file right here will disappear. We could also pass in the absolute path, so we get that with pwd. We'll go ahead and copy this to save ourselves a little bit of typing, clear it out, and type rm, pass in the absolute path, go even further into great-grandchild, and give it the new file.txt. So this would also remove that file. But we're not going to do this because this is a very tedious command to type. It's much easier if we just navigate down to the directory we want to delete a file from, and then type rm in the name of the file. You can see it was deleted from above. And remember, as we're going through this, these two things, this Finder window and the terminal, they are both talking to the file system that the Mac is running right now. So we've deleted a file. Now, what if we wanted to delete the entire great-grandchild directory with all of the files in it? Now, this is the command that I will caution you about using, because it could be a very dangerous command. Not physically dangerous, but you could end up deleting every file on your entire computer by using this command. And that command is rm-rf, which means -recursive-force. So it's going to ignore any sort of errors, and it's going to recurse, or go through every single folder and file within the folders and delete those files and folders. So I'm safe here. You would never want to type rm/rf/. I'm not even going to type it here because I'm so scared to do it, because that would delete your entire computer. And this is not reversible. There's no undo button for doing that. So I know I'm talking about it way too much here, but just please do not do that. Okay, so rm-rf, and what I want to do is delete the current directory. So how would I do that? Well, there is a particular command that we could use to delete the entire current directory, and that is passing in dot or /. They're one and the same. That would delete the current working directory. Now, I always like to be safe with this, so I generally will go up one. So now we're in grandchild right here, and then I pass in the name of the actual directory. So rm-rf great-grandchild. So what that command will do is delete the great-grandchild directory and recurse through that great-grandchild directory to delete file 1, 2, and 3. And as you can see, we just quickly deleted that entire directory. We have covered mostly all of the commands. The only ones left is the copy and move command. Now say I wanted to copy this file right here. Remember, this is the one that we wrote some sort of text into. And say I wanted to make a copy of that file and put it in the grandchild folder. All I would need to do is type cp and go give it the path to the file that I want to copy. So we're sitting currently in grandchild. You can see that here, or you can type pwd. And so we copy and then pass the path, so that is //, which means up one level from grandchild, and then file1.txt. Okay, so that's our first argument, file1.txt, and then we give a space, so I just gave a space, and then we pass our second argument, which is the location and name of the new copy of this file. We want to put it in grandchild, and we'll make it a distinct name. So we're currently in the grandchild directory, so we don't need to give it any sort of path other than maybe // which represents current directory. And then we'll give it a name, something along the lines of commands to learn.text. So what this is going to do is it's going to take all the contents of the file 1.txt and copy it into a new file that it's going to create called commands to learn.txt. As you can see, we now have a new file, commands to learn.txt, and we can see what is in that by typing cat commands to learn.txt. And what do you know? We have all of the text that we had previously written into file 1.txt. Alright, so what if we wanted to move that file? If we wanted to move that file, maybe since it's like a description of what we're learning here, maybe we wanted to put it in the topmost file system directory. To do that, what we would do is type mv, give it the file we want to move, so commands to learn. Remember, we are in the grandchild folder, and commands to learn.txt is in the grandchild folder, so all we need to do is give it the name. Again, we could also do /, which means current directory / commands to learn.txt. And then finally, give it the path to the place that we want to move it to. So that would be /. So if we're in grandchild, we go // up1, // up2. So type that, and then finally one more // to the file system. Okay, we don't even need to give it a name. We can just press enter. And what do you know? It puts commands to learn.txt up into the topmost directory. We just covered a whole lot of commands, and I know it's probably lost on you at this point. I would recommend rewatching this segment of the video maybe 2 or even 3 times until you are comfortable kind of following along with what I'm doing here and understanding where you're at any specific time, PWD, that gives you where you're at, and understanding how to kind of navigate the entire file system. The last thing that I wanted to show is how to get help on these commands. Typing these commands into Google is surprisingly unhelpful. When you type in CP into Google, it's not quite specific enough to get you any meaningful results. What's more helpful is to use the man pages. So to do that, we can type the name of the command preceded by man. The man command will print out instructions on how to use any command in your terminal. So if I wanted to understand what ls did, I could type man ls. And it does not matter where you're at in the file system. You can type this anywhere. You can see now we have a manual that will tell us what this does. It says for each operand that names a file of a type other than a directory, blah, 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 blah. Some of this instruction is very verbose and it's kind of tough to understand at points. But for example, this command we had learned ls-la, and you can see what these flags do, or these options do, by scrolling down. So let's find, there's our lowercase l, -l. It says list in long format, or more verbose format. Then we could find the A, which is probably at the top. Okay, so A, it says include directory entries whose names begin with a dot. So that's our hidden files. So that's just one example of how we might use the man pages to understand the different options for a particular command, or even how to use that command.